Okay, so humor. Well, didn't we just learn about vitreous humor and aqueous humor? And then we're going to learn about humoral immunity, circulating in the blood, humoral immunity. So this is saying hormone, fluid. And in our case, it's going to be what? What's the fluid? Blood, yeah. It's going to be blood. Okay? Approximately, and this is going out on a limb, approximately 50% of blood is water. Okay, 55% of blood is plasma, 90% of that plasma is water. So yeah, we can honestly say that about 50% of your blood is water. So it's no surprise when they use the word humor, humoral, hormones, fluid, blood. The next one is hormone to hormone. Hormone to hormone, and we might as well just do this. Inhibit, excite, or promote, or secrete, or stimulate, whatever word you want to use. So basically we're saying that a hormone is going to turn on another hormone, or it's going to turn off another hormone. And then this was the last thing that we really left off on, neural to hormone. And what were the two primary neuroendocrine or neuroglandular tissues? Sorry, I was like all excited about it. What were the two that I told you guys to focus on? The pituitary's the gland, so what was the neural aspect of it? So you are correct, the pituitary was the gland, so what's the neural? What's the pituitary connected to? Hypothalamus, so there's number one, and then what's the second one? Adrenal gland, fantastic. So that's easy, okay? So we've got hypothalamus, and adrenal. Okay? You know these are going to be on the test. This is the second, third time we've gone over them, so you know it's going to be a test question, so please put some focus into it. All right? It's definitely going to be a test question. So, Kerpow, let's turn that on. Let's grab my little flicker switcher, and we'll go. Now, this is going to go fast, and the reason why it's going to go fast is because we don't have to labor over the effects of the hormones. We just have to go through the gland and what it's secreting. The gland and what it's secreting. There will be some choice words that I'll give you guys, but for the most part, the gland and what is it secreting. Now, we already went through the makeup of the hormones, and as we go through this, it will actually tell you what the makeup is again. So there's a lot of repetition, bless you. And that's another thing. If you see me getting loopy, like, whoa, slow motion, like white shadow. Really? Turbo? Come on, people, it's a cartoon. You got to watch that cartoon. That one's crazy. Okay, if you see me getting all milky and like loopy and everything like that, that's because the amount of pollen that's in the air is actually killing me. And so I take half of an antihistamine, half of one, and usually it doesn't have an effect on me, but sometimes if I'm on an empty stomach, it will actually slow me down. Okay? So just letting you guys know. That's why you don't see me sneezing and coughing and mucus coming out of my mouth and nose and bleeding from my eyeballs. Okay? That little half of a little antihistamine is keeping me sane, kind of. All right? So, humoral, hormonal, and neural. Now we have examples of them, okay? So let's fly through some of it, literally fly. Okay, we already talked about the reflexes. We talked about, and this was the example that we used for the neural aspect of it. There's our pituitary gland, there's our adrenal gland. Remember, there's two parts to the adrenal, the cortex and the two parts to the adrenal gland. We're awake now, come on, chop chop. The cortex and the medulla. There we go, good, good, good. Neuroendocrine reflex pathways include both neural and endocrine components. So, hypothalamus, pituitary. Pituitary gland. Now these are the glands. So guess what? We're in that point now where you're going to say gland, hormone. That's it. So here we go, nice and fast. Pituitary gland, also called the hypophysis. The hypophysis. It's also called the hypophysis. Hey, did you know that the pituitary gland is also called the hypophysis? Yes, it is. All right, where's it found? Sella turcica. You guys remember that? The Toyota Celica? Yeah. Not a big deal, connected to the hypothalamus via the infundibulum. Boom, we already know that. Pituitary gland, well, it uses a second messenger, releases 9 important peptide hormones. Is peptide one of the hormones makeups that you guys have to know? It certainly is. Okay, so here it is. It has 3 different parts. Now, I'm not going to hold you to the 3 different parts, but I am going to hold you to what is secreted from the anterior and what is secreted from the posterior aspect of this bad boy. Okay? So, anterior lobe of the pituitary gland is also called the adenohypophysis. The adenohypophysis. Now, I joked with the student on Friday. No, was it Friday? No, Tuesday. I joked with the student on Tuesday because that was their answer for the anterior lobe. So it's on our worksheets, instead of putting anterior lobe, they put adenohypophysis. And I joked with them. I said, what are you, jumping the gun? Now that's the kind of effort that gives results like B's and A's right there. Is she jumping the gun? No, because we got to it. Okay? So that's the kind of effort. She took one step further and said, hey, anterior lobe, wow, look at that's in bold print. I'm pretty sure that's going to be important. Let's put it down. And she's already ahead of the game. Now she's heard it like 4 or 5 times. Adenohypophysis, the anterior lobe of the pituitary gland. Okay, hormones turn on endocrine glands or support other organs. Hormones turn on. Hormones turn on. I think that's kind of right where we're supposed to be, right there. They turn on. All right, so this is going to go through their different attachments. So the hypophyseal portal system, the median eminence, right? So swelling near the attachment of the infundibulum, where the hypothalamic neurons release regulatory factors. Okay, wow. So this is saying that the actual hypothalamus is doing something first. Okay? So the portal vessels, blood vessels linked to capillary network. Entire complex is a portal system. It ensures that regulatory factors reach intended target cells before entering general circulation. So guess what? It's saying this. I'm going to put some out there. It's going to be stored and ready to be released. Okay, we know it's there, and then when it's released, we know it's going to circulate around, it's going to activate something, and sensing that that's activated, I can stop releasing it. Everybody see how that works? Yeah, so it would be like me saying, hey, Roberta, go turn on the light. Once I see the lights go on, do I have to keep telling her to turn the lights on? No, not at all. Okay, so it's literally as simple as that. Go turn on the lights. Once I see the lights come on, I don't have to keep telling her to turn the lights on. It's already done. Okay? So the entire complex is a portal system, and it's wrapped around the pituitary gland. It's actually wrapped around it. There you go. Okay? This is actually an extremely important image. It actually tells you how this works. Superior hypophyseal artery delivers blood to the capillary network of the median eminence, right? So inferior hypophyseal artery delivers blood to the posterior lobe of the pituitary. But notice down here we've got all of this network. All of this network. Well, looks like it's a whole bunch of outputs. So So we got input and then we got output. A whole bunch of outputs. So it says hypothalamic control of the anterior lobe. Now we're still on the anterior lobe. It says two classes of hypothalamic regulatory hormones. Releasing, which means it's going to do what? It's going to stimulate it, yeah. Releasing is going to stimulate it. And then how about inhibiting? There we go. So once we sense it's active, then we're going to tell it to stop. So releasing stimulates synthesis and secretion of one or more hormones at the anterior lobe. Inhibiting prevents the synthesis and secretion of hormones from the anterior lobe. So we need the hormone to be synthesized and then secreted. And when we don't need it anymore, what do? Tell it to shut off. Rate of secretion is controlled by a negative feedback mechanism. Okay, so let's elaborate on this just a little bit. Just a little bit, just a tiny bit. If you're in your house and you set your thermostat to 70 degrees and the thermostat drops all the way down to 60 degrees, okay, the temperature drops to 60 degrees, your thermostat says, I sense that, stimulate, right? Stimulate. So your furnace turns on, starts heating up, heating up, heating up. Does it stop right at 70 or does it go above 70? It goes above 70, like by 2 degrees at least. Knowing that it's above that temperature, we then inhibit it, tell it to shut off. Because we've already reached the temperature that we need. But we've gone over just a little bit. Just enough. So we stimulate it to heat up the house and then inhibit it to stop. And we'll keep doing that, which is a negative feedback mechanism, and it's also, here's the cool thing, homeostasis. So what are we doing here? We're actually using hormones to control homeostasis. Super cool. This is awesome to think that we actually have a system that says, okay, we're where we're supposed to be, go ahead and send out an inhibiting hormone because we need to shut it off now. So here you go. Releasing hormone up at the top there. We release the hormone, endocrine gland. We secrete the hormones. Oh my God, we found out that they're good to go. So then we go ahead and tell it to shut off. Hormone number 2 is going to tell it to shut off. What we have here is two things going on. We not only have hormone to hormone, but we also have neural to hormone. Hormone to hormone, negative feedback mechanism, neural to hormone. Okay? So, releasing hormone, thyroid releasing hormone, thyroid stimulating hormone, thyroid gland, thyroid hormones. Doesn't get any more simplistic than that. Okay? So the presence of prolactin, boom, goes up. Inhibition. Stimulate, inhibition. Stimulate, inhibition. So we just keep doing that over and over and over again. Okay, so it says variations of the typical pattern of regulation of the endocrine organs by hypothalamus and then the anterior pituitary. The regulation of prolactin production by the anterior lobe. In this case, the hypothalamus produces both releasing factor and inhibiting factor. When one is stimulated, the other is inhibited. Release, inhibit, release, inhibit, release, inhibit. That's all we're going to keep doing. It's a cycle. Okay, and this is just going through all of them. So you can take some time to look these over. Bam. And there you go. It's not overwhelming because you guys have already been exposed to this on a worksheet that I gave back to you today. Okay, so this is just walking you through every single one of them and what it does. Posterior pituitary, wow, this is kind of actually straightforward. Here we go. Antidiuretic hormone and oxytocin. This is called neuro hypothesis, contains unmyelinated axons of the hypothalamic neuron. Okay? We're going to produce antidiuretic hormone and oxytocin. So, direct release of hormones, sensory stimulation, osmoreceptor stimulation. Osmolality. Oh, wow. Is there something in there? Okay? Is there something in there? Well, take a look at what we're talking about here. Oxytocin, well, males, smooth muscle in the ductus deferens and prostate gland. Okay? Oxytocin for females, uterine smooth muscle and mammary glands. So, uterine contractions. Mammary glands. What are we doing for mammary glands? Stimulating milk production, yeah. So what does it say here? Antidiuretic hormone, kidneys. We're going to reabsorb water, oxytocin in the uterus and the mammary glands. What does it do? Labor contractions and milk ejection. Okay, and it just ejects right out of it. Just, okay? Yeah. So there you go. Labor contractions and milk ejection. Okay? Now keep in mind that labor contractions isn't negative feedback. What is it? It's positive. Push, 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 baby, done.
Yeah.
Okay? They can be as simple as 1 or 2 hours or 24 hours. Okay? The ladies that survive the 24 hours, good on you. Because that's some craziness. You went 24 hours? Oh, you're stretching. Okay. Okay, so let me say that one more time. Oxytocin is part of pregnancy, but here you go. Labor contractions and milk ejection. Milk ejection. Okay, thyroid gland lies inferior to the thyroid cartilage of the larynx. Consists of 2 lobes connected by a narrow isthmus. Isthmus? There's a word to say, huh? Okay. So, what does the thyroid gland secrete? Now, it's surrounded by a network of capillaries that deliver nutrients, regulatory hormones, accept secretory products, and metabolic wastes. Okay? Boom, there you go. Triiodothyronine. Triiodothyronine. That's T3, and then thyroxine is T4. Okay? Contains 4 iodine ions, and then the other one contains 3 iodide ions. I don't know where I got iodine from. Probably the word looks like it. Okay? But yeah, what are they secreting? There's what they're secreting. Location. She looks happy. I'm pretty sure they said, we're going to take your picture and then we'll use this. But she didn't know that they were going to use it for that. And they kind of overlaid some thyroid glands on her. Yeah. Some kid's going to be flipping through like, Grandma! She's in the picture. It's awesome. Okay? So, again, where is it and what does it secrete? Now, this is just talking about homeostasis, decreased T3 and T4 concentrations in the blood, or low body temperature, releases from the anterior lobe, pituitary gland. Anterior lobe goes to the thyroid and says, hey, increase the concentration in the blood. Everybody see how that works? So it's going from the anterior lobe to stimulate the thyroid gland to release more T3 and T4. Okay, nope. Thyroid stimulating hormone. So absence causes thyroid follicles to become inactive. Well, that makes sense, doesn't it? Because doesn't it say stimulating hormone? Yeah, it does say stimulating hormone. Neither synthesis nor secretion occurs. Well, that kind of does mean inactive. Okay? Functions of the thyroid hormone, well, it does have functions of it. We will come back to it, but for the one thing that I'd like you guys to just kind of have in the back of your head, in children, essential to normal development of skeletal, muscular, and nervous system. And what was oxytocin again? What did oxytocin do? Milk ejection and uterine contraction. Okay, so cells consume more energy, resulting in an increase of heat generation. It's responsible for strong, immediate, and short-lived increase in rate of cellular metabolism. Kind of gives you an idea of what the thyroid gland does. Okay, if it does increase metabolism and heat production, don't you think all of these will kind of actually go hand in hand? So accelerates the turnover of minerals, stimulates activity in other endocrine tissues, okay? Stimulates red blood cell formation, thus enhances oxygen delivery. Yeah, because that's all part of a sped up metabolic rate. All of it is. So interestingly enough, they're not actually hiding anything here. It's pretty straightforward. If you speed up metabolic rate, what goes along with that? Just think logically about it. What goes along with it? Increased blood flow, increased blood, increased oxygen, increased use of nutrients. Well, does it say that up here? It certainly does. Okay, energy consumption, especially in children. Now, C cells of the thyroid gland, calcitonin. Now, how many people put calcitonin down on their sheet? Couple people did. The other class, about half the class, put calcitonin down. Produces calcitonin, helps regulate the concentration of calcium in the body, inhibits osteoclasts, which slow the rate of calcium release. What do osteoclasts do, peeps? They break it down. They break it down. So this is a negative feedback mechanism. What builds it up? Osteoblast. And what stimulates osteoblasts? Parathyroid hormone. And we're going to get to that, but look at the repetition we've got from 241 now. Bone remodeling, right? Calcium regulation in the bloodstream. Too much, too little. Parathyroid gland, well, guess what it does? Parathyroid hormone. Now, parathormone, same thing. They just shorten it, like we always do with stuff. Okay, produces parathyroid chief cells in response to low concentrations of calcium. It's the antagonist for calcitonin. So, there's our negative feedback mechanism right there. Break down bone to get calcium, build up bone because we've got too much calcium. Found in the bloodstream. There's our parathyroid. There's where they're located. The three effects of parathyroid hormone, well, guess what? We already know this. This is repetition. This is all about calcium. So take a moment to refresh your memories on this. All about calcium. Normal blood calcium levels. Normal blood calcium levels. And we know the two cells that are going to help us with this, right? Osteoblasts and osteoclasts. Okay, there's our homeostasis. And there's our cheat sheet. Thyroid gland and parathyroid gland. Now, if we get into blood and I start talking about calcium blood levels, are you guys going to immediately go back to this? Or do I have to actually say, go refresh your memory back to parathyroid hormone and calcitonin? Remember, I gave you guys a concept map the very first day we were in here. A concept map. What is this right now? It's a concept map. Because you've already had bones, you've already had calcium levels, you already know that calcium is not the most important thing for bone growth. What is calcium primarily used for? Muscle contractions. That's number 2 on the list. Yes, sirree. What's the number 1 thing? Nervous system. Right? Can we release neurotransmitters in the synaptic vesicles without calcium? No. No, we need it. So guess what we also need? the hormones that help regulate calcium blood levels. Adrenal glands. Well, if you didn't just say adrenal medulla, epinephrine, norepinephrine, you're tired. We'll get you a cup of coffee. Okay? If you did say that, then you're rocking it because you're right. Now, what about the cortex? There you go. Stores lipids, especially cholesterol and fatty acids, manufactures steroid hormones, corticosteroids. Okay? Adrenal corticotropic hormone. Now, troph, the term troph just means to nourish. Means to nourish. Okay? 3 different aspects of the cortex itself. So you do need to know these because they're important because of the hormone that comes out of each one. Okay, so you need to know these because of where the hormone is. So, glomerulosa, we're talking about mineralocorticoids. Aldosterone's an example of that. Aldosterone. Okay? Aldosterone's a salt-loving hormone. Okay, it's a total salt-loving hormone. So when we get to the urinary system, we're going to talk about aldosterone all the time. What's the other hormone that helps us retain water? Antidiuretic hormone. Thank you very much. And where's it found? The ADH is found where? What hormone? The hypothalamus to the posterior pituitary. That's a perfect example of a test question right there. The hypothalamus to the posterior pituitary. Okay, aldosterone, what does it do? Well, a secretion response to drop in Na. Sodium. It's a salt-loving hormone. So where salt goes, water follows. Let me say that one more time. Where salt goes, water follows. So this hormone says the drop in Na, blood volume or blood pressure rise in K concentrations. We're going to make sure that we retain Na. Okay? Fasciculata. Ooh, that's a fun word. That's fun. Okay? Cortisol or hydrocortisone. Okay? Converts cortisol to cortisone. Secretion regulation by negative feedback. Has an inhibitory effect on production of corticotropic releasing hormone in the hypothalamus. ACTH in the adenohypophysis. The adenohypophysis, ACTH, adrenal corticotropic hormone. Okay, and then last but not least, glucocorticoids, alter glucose synthesis and glucogen formation, show anti-inflammatory effects, inhibit activities of white blood cells and other components in the immune system. Anti-inflammatory. What causes inflammation? I was just talking about it. What did I take this morning to prevent inflammation? Histamine. Yeah, antihistamine. Okay? Reticularis, network of endocrine cells, produces androgens under the stimulation by ACTH. And what were androgens? Gonads? You're on the right track. Which one? Yours or mine? Mine. Yeah. Mine. You're chuckling. You're like, gonads. He said gonads. Yeah, gonads. Reproductive organs. Okay? So, location? Well, it sits atop the kidneys. Sits right on top of the kidneys. That's 2 parts, the cortex and the medulla, and we know what is secreted from both now. There you go. Capsule, cortex, medulla. And cheat sheet. Yay! Cheat sheet. I'll give you a warning right now. Anything that I've repeated like 3 or 4 times, especially on what it might do, you might have, you guys, yeah. if I just kind of perused over it, but if I, which is funny because that word can mean two things, peruse, go slow or actually go fast. So you got to determine what I did. Okay? So, yeah. There we go, cheat sheet. What does oxytocin do again? Milk ejection and uterine contraction. Okay, the adrenal medulla, well, this is pretty straightforward. It's all about epinephrine and norr. What do they do? Well, we already know what they do. Okay, we know what they do. They speed everything up. But depending on their binding sites, they can actually have some other effects. Okay, so other effects, well, resulting glucose molecules are released into the bloodstream. Well, that's something needed when we're sped up, excuse me. In the heart, stimulation of beta-1 receptors triggers an increase in rate and force of contraction. Rate and force of contraction. Pineal gland. Okay, melatonin. What was the other hormone? Serotonin. Good. Okay, what does it do? Functions. Melatonin inhibits reproductive functions. Okay, protects against damage by free radicals, influences circadian rhythms. Sleep, wake. And I know most of you guys are sleepy right now, but it's time to wake up. That's right. Rawr. Oh, there it is. In the posterior aspect, notice it's over by the cerebellum there. Just kicking it. Having a good time. Saying, hey, look, this is where I'm at. Pancreas lies between the inferior border of the stomach and proximal portion of the small intestines. It's tucked up underneath there. Okay, it's long though. It actually transverse across our entire abdomen. Okay, contains exocrine and endocrine cells. What are the two endocrine functions? Hormones that are secreted. Insulin and glucagon. Okay, exocrine. Exocrine. We're secreting this into the digestive tract. So do we need to focus on exocrine? No, it's good to go over it really quick. So here we go. It takes up roughly 99% of pancreatic volume. Okay, consists of a cluster of gland cells. What are they producing? They secrete alkaline, enzyme-rich fluid. What does alkaline mean? Come on, chemist people. Alkaline. I told you needed to know the pH scale. What is alkaline? Alkalinic. Basic. Thank you. Okay, that thing's gone. It's out of here. It is basic. Basic, basic, basic. What is found in your stomach to help you start the digestive process? Acid. So it is no wonder that we secrete an alkalinic compound to reduce the acidity. Because the only part of your digestive tract that can actually handle acid is your stomach. All the other parts, the duodenum and your esophagus, have difficulties handling it. So when you do this, what happens? It burns your throat. We call it heartburn. What it really is acid refluxing into your esophagus, right next to your heart. Hello heart, hello esophagus. It's burning, so what do we call it? Heartburn. This juice actually helps reduce that when it gets to the duodenum, the first part of the small intestines. Helps eliminate it so we don't get that burning sensation in our digestive tract. Again, only your stomach can handle it. Endocrine, on the other hand, what are we talking about here? Boom. Glucagon and insulin. Glucagon and insulin, alpha and beta cells. Okay? There's our pancreas. Notice it does have a duct, the pancreatic duct. It pops into the duodenum. This is the duodenum right here. And it secretes it in there when there's presence of acid. It says, oh, there's acid there, secrete. So that means it's an exocrine function. The endocrine function, insulin and glucagon, go right into the bloodstream. You say that one more time. Exocrine into the digestive tract. Endocrine into the bloodstream. Okay, blood glucose levels. When levels rise, beta cells secrete insulin. When levels decline, alpha cells release glucagon. Blood release. Blood release. Glucagon, insulin. Okay? Know this. Let me back up. Know this, please. It's important. Okay? We're going to learn more about it, and we're also probably going to have a little bit of a write-up on diabetes, but that'll be later on when we get to the digestive. Because I have an entire digestive homeostatic imbalance slideshow for you guys that I did, so I want you guys to see that. Okay, this just confirms what we were just talking about. Okay, homeostasis, normal blood glucose levels. Insulin talks about where insulin is actually released, how it's released. Glucagon, same thing, where and how it's released. And here's your cheat cell, or cheat sheet. Cheat cell. The last thing I saw was cell. So your cheat sheet. Hormones produced by the pancreatic islet cells. Okay? Insulin and glucagon. What do they do generally? What do they do generally? Okay, we know that they go right into the bloodstream. Okay, so yeah, blood sugar levels. Definitely going to dictate that. Okay, endocrine tissue, other systems. Other systems. Well, digestive tract we'll get to. Kidneys, heart, thymus, gonads. Yeah, those are all things that you guys know that we have glands for. We already know most of the chemicals for them. We didn't talk about any for the digestive system, but guess what? There are some there. Okay, kidneys. Again, we didn't talk about that, but I did mention ADH and aldosterone. The heart, ANP, atrial natriuretic peptide, the heart. Okay, so the immune system, some craziness going on there, and then reproductive system. So, intestines produce hormones important to coordination of digestive activities in conjunction with the pancreas. Kidneys produce EPO. EPO, have you guys heard of that before? Erythropoietin. Erythropoietin. Okay, it's a synthetic version of it's doping. Doping. It's what athletes take to increase their red blood cell count. Okay, so it increases your red blood cell count, and then we have renin also. Okay, renin is part of the urinary system, and we're going to learn about what it does. Renin actually helps with blood pressure. Okay, so this is just walking you through some of the interactions with cholesterol, dietary cholesterol, but I'm not going to hold you to this. Part of the kidneys. Okay, wow. I just mentioned what? Blood pressure. We'll come back to this entire thing when we're in blood. When we're in the heart, circulatory system, we're going to come back to this. So just be prepared to come back to this slide. Heart, natriuretic peptide. Okay, when blood volumes become excessive, action opposes angiotensin, reducing in the reduction of blood volume and blood pressure. So what does ANP do? Reduce blood pressure. We'll come back to that again when we get to circulatory system. Thymus, thymosin, okay, helps maintain normal immune defenses. Kind of all you need to know about it. Gonads, well, produce androgens, testosterone, secrete inhibins in nurse cells, support differentiation and physical maturation of sperm. What does maturation mean? Mature. Literally, that's all it means, is mature. Process or condition of mature. Nothing crazy going on. Oh, gonads, ovaries. Okay, produce estrogen, ovulation, follicle cells. Okay? And there you go. Cheat sheet. Cheat sheet. Leptin. Well, it kind of sounds like lipose, right? Leptin, fat, adipose tissue secretions. Leptin, feedback control for appetite. Okay? So, and there's an overall cheat sheet for intestines, kidneys, heart, thymus, gonads, and adipose tissue. So let's see where we're at for time. How many more slides? Good. So we'll stop right here. I think this is a good place to stop. So 5-minute break, get up, go potty, do what you need to do.